Isn't this fascinating? She charged the rods the same way so they repel each other. But what's really going on? How can the rods affect each other if they're not touching each other?
We've learned about Newton's first law, that an object at rest will stay at rest unless acted upon by an external force. The rotating rod was at rest, and then moved when the other rod came near it, so one of the rods must have been exerting a force on the other. From Newton's third law, we know that the rods were actually both exerting the same force on each other. But how do we explain why they were not touching? Well, think of gravity. Even when you are not touching the earth, gravity still affects you. You fall when you jump. It appears that charges can do the same thing, except they can also repel, whereas gravity can only attract. In the video, we saw that the rods had to be fairly close to have an effect on each other. The realm of effectiveness of the charge's forces is called a field.
Think of a magnetic field, which can look similar to an electric field. You can see a magnetic field when it is revealed by iron filings laid out around the magnet. Electric fields are a lot harder to see in real life than a magnetic field, but we can draw them. So let's start with a positive. Let's call just all positives are blue, and we will call it A. And we have another little test charge off to the side. They are both positive. Let's say that A is fixed, so it can't move. That means that when they're both positive, they are both going to repel. And let's draw that with an arrow right here. These arrows represent the field. That's what we can draw as the electric field for positive charge A. Now what happens if we have a negative charge? We'll make it red, but we still have our little blue charge, our positive test charge. So positive, negative, they're going to attract. So we're going to draw that with an arrow over here, pointing towards it. This is what the electric field looks like for a negative charge with a positive test charge. It looks just like the positive field, doesn't it? Except all the arrows are pointing in.